One variant of a histogram which is not as widely used as an ordinary histogram but is interesting to know about anyway is a very different looking plot called a stem and leaf plot. To get started, here is some sample data consisting of a simple list of numbers, and these inputs use the stem leaf plot function to generate a stem and leaf plot for that data. The stem leaf plot function is defined in a separate standard package called statistical plots, which is loaded here by evaluating needs statistical plots, and after that the plot is generated by the stem leaf plot function. The actual stem and leaf plot is a table where the first column, called the stem column, lists the possible first digits of the numbers in this data, and the second column, called the leaves column, is the sequence of second digits from each number in this data. In this data, the first digit is always a 2 or a 3, so those are the two entries in the stem column. The stem and leaf plot is then constructed by entering the second digit of each data value in the corresponding row in the leaves column. For example, the number 22.5 in the data shows up in the stem and leaf plot as stem 2, since that is the first digit, and leaf 2, since that is the second digit. The number 23.1 in the data shows up in the stem and leaf plot as stem 2, since that again is the first digit, and leaf 3, since that is the second digit, and so on. This stem and leaf plot is, in effect, a histogram with two bins like this one, where each bin has a width of 10. The first bin is the bin for measurements between 20 and 29.9, since those are the measurements for which the first digit is 2. And the second bin is the bin for measurements between 30 and 39.9, since those are the measurements for which the first digit is 3. The label stem units 10 is included below the stem and leaf plot to point out that the width of each bin is 10. The essential difference between the histogram and the stem and leaf plot is that the number of measurements in each bin is represented in the histogram by the height of a bar, and in the stem and leaf plot by the length of a row of digits. Here's another stem and leaf plot for that same data, but with the stem exponent option set to 0, which gives a result that looks a bit more like a typical histogram. And here again for reference is the data. The stem exponent option controls the width of the bins. Specifically, the value of the stem exponent option is an integer that gives the decimal exponent for the width of the bins. When the value of the stem exponent option is 0, the width of each bin is 1, since 10 raised to the power 0 is 1. With these data and the stem exponent option set to 0, the stem column shows the first two digits of each data value, and the leaves column shows the sequence of third digits for each data value. The plot shows that there is one data value for which the first two digits are 22, or equivalently there is one data value in the bin from 22.0 to 22.9. There are three data values for which the first two digits are 23, which means there are three data values in the bin between 23.0 and 23.9, and so on. A disadvantage of stem and leaf plots is that since the width of the bins is determined by the choice of how many digits to include in the stem column, the width of the bins could be 10 or 1, as in the last two examples, or any other multiple of 10, but without making the plot more complicated, those are the only choices. Stem and leaf plots do, however, have the advantage of being relatively simple. It would be easy to construct a stem and leaf plot like this, for example, by hand using nothing more than a paper and pencil.